Welcome back to Learning with Merit. Today we're going to look at Python data types, variables, and some basic function calls to get us started as new Python programmers. First, we're going to look at some general syntax and rules for writing Python code. Then we're going to look at the basic data types that we need to know. Then we're going to look at what are literals, take a look at variables. We'll take a look at type annotations for declaring the type of a variable. We'll look at aliases, the print function call, and the input function call, and then finally we'll take a look at some basic nesting or putting one thing inside of another. Let's talk about the general syntax for writing Python. So anytime you hear the word syntax, it is the rules for writing a language. So we're going to take a look at some of those rules for how we write Python so that the interpreter can correctly interpret what we are writing. So first we're going to take a look here. We need to know that our code is executed from top to bottom and left to right. So just like you might read a book, whenever you read a book, you start at the top and you read line by line from left to right as you go down from top to bottom. So if we look at this in Python, we might have something that looks kind of like this, where I have line numbers like I do in my little editor here, but I've numbered these for you 1 through 18. We're going to read each line as we go down. We also need to remember that we're going to read into indentation. So as we indent, we're going to read into that, and that's going to define something very important about Python as well. Now, in Python, every single open needs a close. Now, you could say open symbol if you'd like, but anytime we use certain symbols, we must open and close them. So here we have single quotes, must have an open and a close. Here we have double quotes, must have an open and a close. Same thing for parentheses, square brackets, and curly braces. If you do not open and close these, even if you have a bunch of stuff in the middle between them, if you don't open and close them, you will result in a syntax error, which is going to cause you a problem. And there's a good use of the word syntax. Syntax errors are errors in which you have made in when you are writing the language. You haven't written it correctly, and so we result in an error. Next, indentation is required in Python. In a lot of other languages, we use curly braces, for example, to indicate the context or scope of a particular code block in our code. But in Python, we use indentation to do that. So we might use that with ifs, elifs, elses, whiles, fors, function definitions, and class definitions, and maybe a few other things. But those are definitely the main ones. So here we go. Let's take a look at this. We use this to define our scope or our context for our code blocks. This means whenever we run some code, there is a scope or an area in which the code is aware or it has a relationship with something, right? It'll be a little bit easier if we take a look at what this means. I'm going to use a triple dot for a placeholder, or this is also known as an ellipse as a placeholder. And this is just for stuff that's not super important right now as we're talking about this. So here we have a basic conditional, right? You see, notice how I've indented 4 spaces here. This code block right here belongs to this if, right? And then when I unindent, now I'm no longer inside of this context here with this code block. Let's look at the rest of them. There's an elif, we're doing the same thing. And the else, we're also doing the same thing there. We indent to go inside the scope, and we unindent to exit that scope. Then if we look at while loops, we're going to do the same thing. Indent to enter the scope, unindent to exit the scope. Same thing for for loops, and same thing for function definitions, and even the same thing for our class definitions. So remember, in Python, when we indent, this has to do with the scoping or context of our code. And that'll make a little bit more sense as we start to write some of these things in later videos and lessons. So let's look at the Python programming style guide now. So if we take a look at this, we want to use a 4-space indent and no tabs. Now, it's important that you understand that editors like VS Code tend to automatically convert this for you. So like I use tabs, for example, all the time. I hit the tab key on my keyboard. But there is a difference between the tab character and the actual 4 spaces that what VS Code will do for you whenever you're working in Python, or whatever editor you're using. If you're going to use something that is a little less advanced, then you need to make sure that you're using spaces. Now, 4 spaces are a good compromise between small indentation and large indentation, and the whole point is to make this easy to read while also allowing for plenty of nesting if necessary. And then if we use tabs, we introduce confusion, and I promise you, if you mix tabs and spaces, you're going to get weird syntax errors. It's going to be really hard to track down. So make sure that if you're not using something like VS Code to do this for you, that you be aware of that. Now, wrap lines so they don't exceed 79 characters. Again, editors like VS Code will help you know where you're at on that. There's a couple things that I've turned off to make this not so cluttered. One of those is telling me how many characters deep I am. Use blank lines to separate functions and classes and larger code blocks. For example, you'll notice I use a lot of blank lines to try to make this a little more clear to you as we're going. And then when possible, we want to put comments on a line of their own. And this is just to make things cleaner to read. And then last, or second to last, we want to use doc strings to document functions and classes. This is to explain what these functions and classes are supposed to do to other people who might be looking at our code, and even yourself. It is important that you know what your code does. And if you come back to some code that you haven't documented very well, it may be difficult for you to figure out what it's doing. And then we want to use spaces around operators and after commas, but not directly inside bracketing constructs. Now here's what that means. If we take a look at a piece of code here, after a comma here I've added a space, and between the plus sign here I've also added a space, but right after a parentheses or right before a parentheses I do not add an extra space, and that is ultimately what this means. The parentheses are the bracketing constructs, and the operators and commas are what we want to add a space after. And then we want to name our classes and functions consistently as best we can. And of course, this is a really hard thing to do. But here is how we name them conventionally. We're going to use upper camel case. And here I have demonstrated it for you. We want to use an uppercase letter for each word. And we're just going to join those words right together. This is going to be how we create our classes. And then we want to use lower snake case with underscores for things like functions, methods, and while it's not written here, also variables. And then this will come into light more later when we talk about objects and creating classes. We're going to use the self keyword as a name for the first method argument. All right, so that is our style guide for Python. Now, one little thing that I'm going to add on here is this little sentiment. To a computer, code is either perfectly written or it is wrong. It will do you a lot of good if you will follow this little phrase and treat it as the truth, because it is. To computers, it's either perfect or it's wrong. If it's not exact, it's wrong. It won't work. It won't compile. It won't run. So remember, to a computer, it is either perfect or it is wrong. Now we're going to look at how we store data and use data, represent data in Python. So we're going to look at what data types there are. First, we're going to talk about beginner data types, or data types that you should work with as a beginner in programming so that you can get a good understanding for the different things that you're going to do. They're also easy enough that there's not too much going on, but we are also going to go over all the data types here. We're just going to start with the beginner ones. So literals, these are actual values. So I'm going to start by just showing you literals. I'm not going to show you anything else other than the literal data that you are looking at. So these things do not represent anything else. They represent what they are. So first, we talk about Booleans. Booleans are true or false values. Here's how we write true in Python. We have integers, which are whole numbers. Here's how we might write the integer 5, for example. We have floats, which are what we typically think of as decimal numbers, but really they are floating point numbers because of the little point that they have. So that is why it is called a float. We have characters, which are just single symbols, right? We're going to use double or single quotes for them in Python. Then we have strings, and really a character is just a single character string is what it is in Python, but we can also have multiple character strings. And remember, this is something important to understand. Even a space is a character to the computer. We have to represent it somehow, and even to us humans, we don't see that as anything, but it is something, in fact, to the computer. So again, when we use text, we call it a string. We put it in single or double quotes. Then we have a list or a collection of information, collection of data. You could have a collection of any of these. You could, in fact, even in Python, you could have a collection that stores all of these different data types. So we call this a list, and it contains multiple items called elements. So A is an element, B is an element, C is an element. And then it is also indexed, meaning that when we look at a list like this, we have values to represent each location, and that's how we're actually going to work with lists later. This is how we access each element. Think of it like if I gave you a piece of paper and had a list on it, and I said I wanted you to read number 3. Well, how would you find number 3? You'd go find the number where it says 3 next to it and read what that says. It's the same thing with lists in Python. We need sort of a number to tell the computer to go to so that we can read it. And you'll notice that our list starts at 0, and there's actually a really good compelling reason for that. It is how lists are actually stored in memory. So when we go find this list in memory, the location of the list is actually the location of this first value. And so we use offsets to find these values. Well, if we use an offset that isn't 0, then we would skip the letter A here. There are more data types, but these are the main ones that you're going to use as a beginner. So if the rest of this confuses you, maybe you come back to it later. But this will get you started. Booleans, integers, floats, characters, strings, and lists will get you started in Python for sure. All right, let's look at some of the other stuff that we can do. So all data types. We can classify these into 2 groups. Basically, we have mutable data types, or you can change the data that it holds. These are going to be things like lists, dictionaries, and sets. I can change the values that are stored in those things. And then we have immutable, meaning that you cannot change the data that it holds. And these are going to be things like numbers, booleans, strings, and tuples. So your number types like integers and floats, we can't change them. We can make a new one, but we can't change what they are. Right? We can't change true to something else. Okay? We have to make false and then use false. Right? So you can't really change these values, and that's why they're called immutable. So let's look at a couple things we can do. One, there is a built-in little function that you can do called type, and you'll notice that we have the name type and then open close parentheses. This is used to check the type of data, and then we stick whatever we want to inside of those parentheses, and it will bring back to us the type of that data. So if you're ever curious as to what type a particular piece of data is, you can use that function. For large numbers, we can use underscores to make them more readable. So here we have a rather large number, and I've used underscores to make it a little bit more readable. And you'll see this is meant to represent the output that we would get if we were to print it out to the screen or to a file. And you'll notice that it doesn't output with the underscores. So it makes it easier for us to read while we're coding using these underscores, but doesn't actually affect the output. We can also use scientific notation, and it's available. We use the letter E to represent the times 10 to the power of part in scientific notation. So if you don't remember scientific notation or never used it, I recommend that you go and get a little refresher on that. But basically, here's how we use it. And for those of you who've used calculators before and have noticed that we use the E key that way, this is another way in which we might use that E key, and so hopefully that makes it a little clearer to you why calculators use that E key like that. Anyway, notice that this is 1e to the 9, which is a much simpler way of writing this very large value. The only difference is it brings back a float value. You notice that has a point right there, a floating point. So notice that it returns a float because that is important to know whenever you're working with that data. Now, complex numbers where we need imaginary units, right? This is the square root of -1. Instead of using I, which is a character that we use quite often in programming, we have replaced it with J. And so we're going to use 1J to represent a complex number there. Again, if you don't know what complex numbers are or you don't plan on using them in programming, it's not super important, but it is nice to know that that is a data type that you can use. Here we have a tuple. A tuple uses parentheses. It's a lot like a list, but it uses parentheses instead of square brackets. It's ordered, immutable, and it allows us to have duplicates. What that means, by the way, immutable, you cannot change the values. Here we have a set. This is unordered, meaning it doesn't have a specific order to it. And if you try to print it out, it would print out in different orders. It's unchangeable, unindexed, and allows no duplicate members. So we can't have duplicate values in a set. Then we have a dictionary here. Dictionaries are key value pairs, and we separate those with a colon. They are ordered, they are mutable, and they allow no duplicate members, so we can't have duplicate values as well. We have additional data types that are defined by classes. Basically, you can use classes to define any data type you possibly could think of. And that's one of the powerful things about object-oriented programming is we have ways to define more complex types of information. And so here's an example. We have the range function. This represents a sequence of numbers. And so this will bring me back a sequence of numbers from 0 to 4. So 0, 1, 2, 3, and 4. And then we have something called a byte array. This is going to bring back a sequence of bytes for the word hello here. And then we have a very special type that we all need to know called the null type. In Python, we use none to represent the null type, and this literally means nothing. That's what null means. Let's look at data literals. So literals refer to a notation for representing a fixed actual value. So this doesn't represent anything else. They do not represent anything else. They are what they appear to be. So if we take a look at this, here's a Boolean literal, true. It doesn't represent anything else. It is the value true. Same thing for 10. This is an integer literal, 2.17 float literal, 5j, a complex literal. Here's hello in quotes. This is a string literal. Here is square brackets, and then we have string literals inside of that. So this is a list literal that stores string literals. Then we have a tuple literal, you'll notice by the parentheses, that stores string literals. And then we have a set literal, also that stores string literals. And then finally we have a dictionary literal that is storing key value pairs where the keys are string literals and the values are integer literals. And so this is what different literal types of data look like in Python. Next, we're going to look at variables. So variables are containers that store data values. And variables are really useful because oftentimes we don't know what data we're going to be working with, and so we need something to represent that data that we don't know, just like you do in math problems. So we're going to use a single equal sign, just a single equal sign to assign a value to a variable. We call this assignment. Then we say the equal sign must always be on the left side of the operation. It's very important that you do that because the computer does not understand any other way. So we're going to look at a variable stores a literal. Here we have my variable named called container. You'll notice that it's not in quotes or anything. Then I use a single equal sign, and I have placed the value hello world inside of container. So now container stores the value hello world and can be used just like this value. So I could pass container around and it will store hello world for me. So let's look at some other variables we could assign. Here's A. I'm going to give A the value hello world as well. We're going to give B equal to 5, C to 3.14, D equal to false, E equal to a list, where the list is A, B, and C character values. Now, we could also do this on one line. So you notice I did that all on separate lines. We could also do this on one line. So I've added a semicolon here at the end. So F is equal to 2, then we add a semicolon. Now I can do G equals to 3 on the same line, and a semicolon, and now I can do H equals 4 on that same line. And so now I have all of these on the same line, and it helps me save a little bit of space in my program. So we use that semicolon. Or I could also do it this way. What I could do is I could do I, comma, J, comma, K equals, and then the values in the same order that they should be given. So 5, 6, and 7. So here I is 5, J is 6, and K is the 7 value. We can change the value of variables by reassigning them. So this is important sometimes too. Maybe you want to do some sort of operation and change the value of a variable as you're working on it. So now we have a equals 0. Well, to reassign it, I just do a equals 1. So now a equals 1. So on line 199, a is 0. But on 200, a is now 1. And on 201, a is now 2. If I print a at this point, it's going to print out the value 2, or whatever the last value it was assigned. Okay? It's not going to go back up here and grab 0. But if I moved print a up to line 199, it would print out 0. Okay, so that goes back to our top to bottom, left to right of how our code executes. Next, there are some rules for how we name variables. First of all, they are case sensitive, so lowercase a and uppercase a are not the same thing. You must start with a letter or underscore. You cannot start with a number, obviously, because we have numbers in Python. We don't want to start with a number. It's going to confuse the computer. You can only contain lowercase a through z, uppercase a through z, 0 through 9, and underscore characters. So basically, alphanumeric characters plus underscore. By the way, if you've never heard that term before, alphanumeric meaning these things, alphabet characters and numeric characters, and then we add the underscore. You cannot use spaces, and variables should be named after what they store or represent. Okay? This is usually a good 9 times out of 10 a bad practice. Right now I'm using simple names because they don't really store anything important to my program. They're just examples. But in general, using single letter variable names is a bad idea. Let's take a look at some legal variable names. Here is var equals 0. Perfectly valid. Here is underscore var equals 0. Here is underscore var underscore AR. Right? Underscore V, sorry, underscore AR, like that. You could do an uppercase in the middle. You could do all uppercase. There's actually a special case in which we do this. It's for constants, so generally you don't want to do that. We'll talk more about constants later. And then you have var 1. You can use numbers, they just can't start at the beginning of the variable. We also have some illegal variable names here to take a look at. If we use 1 at the beginning, this will not work and it will result in a syntax error. In fact, you'll notice I put this in a doc string or triple quoted string so that it won't result in an error and make it hard for you to read. Then we can't use a dash character because it does not meet our alphanumeric plus underscore requirement. We can't use a space. We can't use, again, that special character. And we can't use all special characters either. So these are some illegal variable names that we can't use that will result in an error to the computer. Let's talk about aliasing. So aliases in Python. This happens whenever you assign one variable to store another variable, and we call it aliasing or aliases. So if we take a look at this and how this works, the variables are going to pass a reference to the data that they store. So think of it sort of like a mailbox location, right? So it's like, I know where the thing is at, right? Where to go get the mail at, and whatever's in there, doesn't matter how many people know where that, mailbox is, what's in that mailbox is going to be the same for all of those different people, right? So if we take a look at this, we've got a equals some text. So A is pointing to this value, some text, in memory. And then if we take a look at this, we're going to create A, B, and C as aliases, and they're going to point to this same data called some text. So B is equal to A, and C is equal to B. So since C points to B, and B points to A, and then A points to some text, that means A, B, and C all point to this some text value. So if we print out B and print out C, we get some text for both of those. Now, if we have A point to a new value, so we change where A is pointing. We didn't change where B and C are pointing, we changed where A is pointing. So, because they're passing around this reference, whenever we break what A is pointing to, right? A is now looking at a new value, while B and C are still looking at the same value, some text in memory. We haven't changed what B and C are looking at. Remember, A handed off a reference to where to look. Then here we change B, and now you'll see that A is pointing to A was changed, and C is still pointing to some text even though we changed B. B is now just pointing to a new location. And then C, now I'm going to change it. C was changed, and you'll notice that that didn't affect A or B because they were pointing to new locations. Now let's say that we have a mutable data type. So if A, B, and C point to a mutable data type like a list, a change in that data is reflected in all of those variables that are pointing to that data. So here we have A equals 1, 2, 3 is a list, and then B is equal to A, C is equal to B. If I then change the first value, so C at 0, meaning the number 1, if I change that to 999, and then I print A, B, and C, you'll see that they all end up with the same exact value. And why? Because they all point to the same data in memory. So type annotation in Python is a way to declare variable type. Now in other languages, like Java for example, you are required to state the type of data that a variable stores. Now in Python this isn't true, but that doesn't mean that that's not still a very useful thing for things like documentation of your code. So while this is not required and is also not enforced by the interpreter, it is never a bad idea to document your code by telling us what type of data you expect a variable to store. So let's take a look at how we do that. So remember, we want to declare the type of data a variable is expected to store, but it is not enforced. This is super important. It is not enforced by the interpreter like it is in other languages. Then we have our syntax for this. We have the variable name. We're going to use a colon, state the type, and then equals our variable, or sorry, our value, that we want it to store. So here we have Boolean is my variable name. Add a colon, and then I want it to store a bool for Boolean data type, and that is going to be equal to true. Same thing here. I have num for my number variable. Then we have colon int equals 10. And so on and so forth. Flow for float, 3.14, Unreal, colon complex, 1J, string, colon str, hello world, list1d, list, so on and so forth as we go here. So this is how we can declare the type of data that a given variable is expected to store. And then there are actually some tools later as you get better at programming that this will be very helpful with because you can sort of hover over and see, oh, this is supposed to store a dictionary, but it's not storing a dictionary, and maybe there's something wrong with my code. So this is how we annotate our types in Python. Let's look at the print function call. So the print function call is all about printing out data to the standard output, which we call standard out here, or to a particular file. This is not about printing a piece of paper out, for example. Here is the standard way that we would call the print function. So print is defined for us in the standard library of Python, and it is a function call that we were making right here. So the name of the function is print, and then we have open and close parentheses, and we're going to stick arguments inside of those parentheses. So right now when I just do this, I've got nothing over here, but that's actually not true. It prints out a new line character. So it moves your cursor down one. So if we did this, it would just print out a new line. If we take print and we actually add an argument, here I've added the argument true to print. What it's going to do is now print out the value true. And let's take a look at some other things we could print out. So we got print 10, print 2.17, print 5J, hello world, and then lists, tuples, sets, and dictionaries. So we could print out all of these different literal values as we go, and it's going to print them out to the output or the console, and or even the terminal, for example, which we will see down there towards the bottom. If we want to print out multiple values, we can separate them with a comma in our print statement. So there's print 1, 2, 3, and 4. The default is to add a space between each of those values when it is printed out. So it adds a space, and then at the end it moves to the next line. If we want to change that so that it's not moving to the next line automatically, and we want to stay on the same line with our print, we are going to change this end parameter. So by default, it moves the cursor to a new line. We're going to use end equals and then open close quotes, which is just nothing, an empty string, in order to stay on the same line. Or we could do all kinds of things. We could add spaces, we could add different characters there to go at the end of every single line if we wanted. So here we've got print and hello. Or sorry, we got hello and world. And then it will print hello and world on two separate lines. Or what we could do is we could say print hello, comma, end equals, open close quotes, and this will get rid of any character at the end. And then we print world, and what it does is it prints hello world right together. You'll notice there is no space there because I did not add a space. Then we've got this sep parameter for separator. This specifies a separator between each value. So if I did hello, comma, world, and then sep equals a colon, and by the way, the default for this is a single space, but sep equals a colon, then what I get is hello, colon, world, like that. And then, of course, at the end, it moves to a new line. So it would actually be hello, colon, world, new line character, like that. There's also the file parameter, which you won't use much until maybe later. But it specifies a file to write the output. The default is it writes to the standard output, which is the console or your terminal. But you could also specify a file. So we could say print hello world, and then file equals a file name or a file path. And then we have the flush parameter. Again, this is something that you'll use a little more as you become a more advanced programmer, but it specifies if the output buffer will be flushed after printing. So we can do print hello world flush equals true, and by the way, the default is false, so you could just leave that off, of course. Now the output buffer refers to a temporary storage area where the data to be printed by the print function is held before it's actually displayed, and this has a little bit to do with efficiency. But when you call the print function, Python doesn't immediately write it to the console or a file. Instead, it's going to store that output in its buffer and this buffer until certain conditions are met where it then actually prints them out on the page. I mean, again, this file and flush parameter are going to be a little more advanced programming topics for later. The input function call is going to pause the program and wait for the user to provide some form of input data. So here we have what the input function call looks like. And again, this is a built-in function that is defined in the standard library for us so that we don't have to write what it does. And we don't even really have to understand how that definition works other than it's going to take in some input. So here we have the name of the function and then, of course, parentheses right after it. And inside those parentheses, we're going to provide any arguments necessary for our function. Now it will work just like this. It'll stop here and it'll wait for the user to type in a value, and it's going to read from the standard input. Now we could also add a prompt parameter. So we could say prompt equals inside of that. So this is our parameter and we're going to provide the argument for that. This is the argument right here. This is the prompt for the user, and that would then prompt the user for a whatever we wanted it to, right? It says this is a prompt for the user is what it's going to say, but it could say whatever we wanted it to, right? And this is what we call a keyword argument because I'm saying I want specifically the prompt to be this. But we don't actually have to do that. We could just do input and provide the prompt, and this is what we call a positional argument, and it's because there's only one parameter for input. It's called prompt, and it's the only one, so we could just go ahead and pass it just like this as a positional parameter, and that would work as well. So either one of those that you're comfortable with will work. And then if we want to store that user input for later in our program, then what we're going to do is we're going to use a variable. So I created a variable called user input here, and that's going to be equal to the input call. And inside the input call, I've provided a prompt. It says, please input a value. Now what's going to happen is this input call is going to return whatever the user types in. And then user input is going to store that value or point to where it actually ends up in memory. Then we could also ask for multiple inputs. Here I've got first name and last name, and I could ask for first name and store it here, and I could ask for their last name and store it here, and then use that later in my program as well, like printing them out, for example. Then we could also use numbers as input, but this becomes a little more tricky. By default, input is going to treat each value that is input as a string, so we're going to need to convert it to use numbers. So here I'm going to store an integer, and I'm going to use this little function right here called int to convert to an integer. Then I'm going to call inside of that by nesting. I'm going to nest inside of that the input function. And then inside the input function, I'm going to use the argument write a whole number. And so what will happen is I'll write a whole number. Input will return that as a string. And then int, the thing on the outside, will convert that string into an integer. And now I have a number stored in my program. I can do the same thing with float. I use float as my, it's technically called a constructor in this case, but it's going to cast or convert to a floating point number. It's going to take the input, so I call the input function call inside those parentheses, and then I'm going to ask it to write a decimal number, and the user will write a decimal number in here, and it will be returned as a string, and then float will convert that string into a floating point number. Nesting in programming and nesting in Python is all about putting one thing inside of another. So let's look at what this actually looks like as a programming concept. So here we have a few examples. So a nested list is going to be a list of lists. So here I have my square brackets to define a list, and inside of this I have my first list, my second list, and my third list. And I want to make sure that I separate those with commas like this. Now, if we have nested conditionals, it will look like this. We're going to use indentation. So a nested conditional, you see I have an indented if under this if. So this if is inside of that one. And then I have a third one inside of that one. And then we would have some code block here. So you notice it's all about the indentation. Same thing with while loops. I have a while loop inside of a while loop inside of a while loop. Right? And this is denoted by the indentation level as we go. Same thing with for loops. I have a for loop inside of a for loop, and then a for loop inside of that for loop. So I have a for loop inside of a for loop inside of a for loop. Right? And this is what it looks like as we nest things. We are placing one thing inside of another. A great example of this that you will actually run into fairly often is function calls. So here I have the print function call. Inside of that, I am calling the int function. Inside of the int function, I'm calling the input function. And inside of input, I am providing an argument called type a number. This is the prompt. So what's going to happen is input is going to run first. It's going to ask you to type in a number. You'll type in a number. It will return a string representation of that number. Int will then convert that to an integer, and then print will then print that integer value out to the standard output, in this case, the console. So this is what nesting looks like in Python, and it really helps if you can break it down in your mind how we are nesting these things in different ways.